solving quadratic equations by completing the square. So all we're going to be doing today is just using everything that we have learned about completing the square, and we're going to do exactly the same process, except now we're going to solve it. So we're going to not just factorize it, we're just going to come up with x equals whatever, or x equals whatever. So let's have a look at our very first example. I'll put the screen up here. So if I think about it, I'm taking my first term and my second term. To complete the square, I'm taking this -4 and I'm halving it and squaring it. Because it's negative and I'm going to square it, I'm always going to get a positive. And if I halve it and then I square it, it looks like this. I'm taking the 4, halving it and squaring it. So I'm going to keep it in that form just for now. Now, because I've added that on, I now have to subtract it so that I haven't actually done anything to this equation. And I've still got this +2 and it equals 0. So the reason I've kept it in the form 4/2 is that it can tell me what goes into my perfect square. So it's x, 4 divided by 2 is 2. So that goes into the brackets and it's squared. And then I'm minusing 4 divided by 2 is 2 and 2 squared is 4 plus 2 equals 0. So now I've got x minus 2 all squared, and -4 plus 2 is -2, and that equals 0. Now it's almost looking like the sum and difference of two squares because I have my first term squared, and now I'm going to subtract. Now to get 2, I have to square root it, and to square it will bring me back to 2. So now I've got the sum and difference of two squares, -2 minus √2, and x minus 2 plus √2 equals 0. And so I'm nearly ready. So now I just have to simplify this. So I've got x minus 2 minus √2 equals 0, or I have x minus 2, sorry, I should say plus √2 equals 0. So solving the first one, I've got x, I'm taking the 2 to the other side so it becomes positive, and the √2 to the other side so it becomes positive as well. Or I'm taking the -2 to the other side, it becomes positive, and I've got minus √2. So here are my two solutions to this problem. So now it's your turn to have a go. I suggest pausing the video, having a go at number 2, and then coming back and checking that you are correct. So having a look at question 2, I've got x squared plus 6x. I'm taking the 6 and I'm dividing it by 2 and squaring it. And because I've added it on, I'm now going to take it away as well. And I still have a minus 11 on the end, and it equals 0. So I get x plus, now 6 divided by 2 is 3, so it's x plus 3 all squared, minus, well, 6/2 is 3, 3 squared is 9, minus 11 equals 0. So I get x plus 3 all squared, and -9 take away 11 is -20 equals 0. So it's x plus 3 all squared minus, I'm going to have to square root my 20 to square it. So now I have the sum and difference of two squares. So I have x plus 3 minus √20, and I have x plus 3 plus square root of 20 equals 0. So now I'm going to simplify that. I get x plus 3 minus √20 equals 0 to find my solutions, or x plus 3 plus √20 equals 0. So I get x equals -3 plus the square root of 20, or I get x equals -3 minus the square root of 20. Now the problem with the square root of 20 is that can be simplified. So this is -3 plus, and that simplifies to 2√5, or x equals -3 minus 2 root 5. Another way we could have written this is -3 plus or minus, because that's the only thing that's changing, 2 root 5. So x could equal -3 plus or minus 2 root 5 is another way of writing that. Have a go then at doing question 3. Pause the video, see how you go. So looking at question 3, x squared minus 3x plus, I'm halving 3 and squaring it. And then I'm taking it off. And I've still got that plus 1 and it equals 0. So this becomes x minus 3 over 2 all squared. And if I use my calculator to do this part, I get 5 over 4 equals 0. So I almost got a perfect square. So to make the other side a perfect square, I have to square root it and square it and make it equal 0. So now I'm going to say x minus 3 over 2 minus, and this becomes root 5 over 2. And then I've got x minus 3 over 2 plus the square root of 5 over 2 equals 0. Because remembering the square root of 4 becomes 2. So now I'm ready to solve this. I've got x minus 3 over 2 minus root 5 over 2 equals 0. Or I have x minus 3 over 2 plus root 5 over 2 equals 0. So I get x equals 3 over 2 plus root 5 over 2, or x equals 3 over 2 minus root 5 over 2. And we can leave our answer like that, or we could say x equals 3 over 2 plus or minus the square root of 5 over 2. Or you could even see we've got a common denominator. So we could have also written it like so. Up to you how you would like to do it. If you have any questions, see me in class. Bye.